So if you can see my screen, say yes in the chat. If you cannot see, say no. This is the PowerPoint. If you can see it, tell me in the chat. So everybody should see it. Yes, very good. Okay. All right, so today is the first lesson of linear equations and applications. This is our first unit of advanced algebra, which is basically covering the major topics in algebra 2. There are a couple things that are more into the pre-calculus side that you don't really need to know, but I'll be covering the major topics of algebra 2 that you'll learn in school, and I'll also provide some additional insight on some theorems and stuff. Okay. So today's schedule, we're going to go more on linear equations. So these are not the old linear equations, right? The old linear equations, very easy, right? You already know how to solve them. So I'm gonna show you some more linear equations where it's more complex. So also inequalities, we're going to also review some inequalities and also look at some absolute value equations, and I'll give examples along the way. All right, so let's try this. So again, an algebraic equation is a mathematical statement where two algebraic expressions are set equal. So for example, like 4x plus 2 is equal to 2, right? Then x is equal to 0 because you move 2 to this side and then divide by 4. So the big idea here is to isolate the variable. By isolating this variable, you need to use inverse operations, right? So I'm sure a lot of you know what inverse operations are, right? So let's just review what are inverse operations real quick. So what is the inverse operation to addition? It's going to be subtraction, right? And the inverse operation to multiplication is going to be division. And then, for example, you're taking x to the power of b or something, x to the power of b, and the root b of x would be the inverse of that. So for example, you're squaring 2 and you're taking the square root of 2, right? Those are inverse operations. So are there any questions on this? There should not be much questions because this is still review. So I want to make sure we have a smooth transition from algebra 1 to algebra 2. So there's not much we can talk about anymore with inverse operations. It's just these three, the plus or minus, multiplication, division, and then x to the b and the bth root of x. Right. So now I'm going to go over this example of this linear equation. Right. So it looks pretty normal, right? You would do what you would normally do, right? You use the inverse operations to isolate the variable and then get what it is. So let's just do that real quick. That is the first step. There's actually 2 steps to this. So let's see who wants to volunteer. Does anybody want to volunteer to show me, to help us how we can solve this? Right. So are there any volunteers on how? Okay, we have some volunteers. Evan, very good. So Evan, would you like to unmute yourself and show us how to solve this?
Should I annotate on the screen or?
Evan, your voice is a bit quiet.
So should I like
turn up the volume or something?
Should I explain or like annotate?
Oh yeah, okay. Are you able to annotate?
No, I think you disabled it.
Oh, all right. That's fine then. Then you can just explain what we can do.
So basically you just want the x to be isolated. So you subtract 2 on both sides and then you multiply it by and then both sides you multiply it by x minus 2. So you got x equals something. I haven't done that yet.
All right, so if you multiply x over x minus 2 times x minus 2, you're going to obviously these cancel out, right? It's going to get x. All right, and then similarly, what do we get next?
And then you can cancel out x on the right, you can cancel out the x minus 2 and the x minus 2.
All right, and don't forget, you must also multiply x minus 2 to this -2. So don't
then
forget to do that.
Subtract
And then
2,
you get something like this, right?
yes. And then you get x equals 2x minus 2 minus 2x plus 2, which is
Okay, so first of all, these x's cancel out, right? 2x minus 2x, that's gone. And then it's -2 plus 4, which is basically just 2. So x is equal to 2, right? X is equal to 2. Are we done?
I think, I don't know.
So this is the part where you start with algebra 2. So when you go to algebra 2, you're most likely you're going to start with something relating to linear equations like this. So the difference between the algebra 1 linear equations and the algebra 2 linear equations is that you need to check these. You see, x is equal to 2 in this equation, but as you can see, there's a denominator, x minus 2, in the denominator. So because x is equal to 2, that makes x minus 2 equal to 2 minus 2. But then you have a 0 in the denominator. And when you divide something by 0, it is undefined. So do we actually have an answer to this linear equation here? We actually don't have an answer. So the second step, the first step, of course, is to solve this x with this, to solve the x with the inverse operations. And the second step is you need to actually check your work, right? You have to check your work here. So remember, this is key step. This is a key step. You must check your work. So when you have a variable in the denominator, you must check your work by plugging the x back in, right? And as you can see here, x is equal to 2 does not work. So the answer is no solution. Are there any questions? All right, so no questions, then I'll keep going. So
I thought x equaled 4.
excuse me, what was that?
I thought x equaled 4.
X equal to 4? How did you get that? Who was that? Is that Kaylee or Caitlin who was talking?
Me.
Okay. So, are you talking about this calculation that you don't get?
Oh, never mind. Sorry.
Oh, okay. All right, then, so no questions. Then I'll keep moving. So that is one example, right? That is one example. So of what we, okay, so after that we have multivariable equations. So I might want to do another example about that. So let's see here. So all right, so that's one example. So let's move that to the side for a second. So let me erase all of this and let's do another example. So this example was about no solution. So usually in algebra 1, when you solved the linear equation, you usually had one solution, right? So in this one, x is equal to 2, therefore there's no solution. Right. So let's do another example about linear equations. So if you have something like this, right? So this one is no solutions. And you might ask, is there a case where there is all real numbers is the solution? There is. And this is an example of that. So when you distribute this, you can actually see it's going to be 10x plus 2 times 2, which is 4, right? Using this distributive property. Okay, and then you get 10x plus 4 also on this side. And this is very weird, right? Because you get the exact same thing on the left side and the right side. So you can actually just cancel everything out. You can cancel everything out. 4 cancels out. 10x cancels out. Then you get what? Like 0 plus 0. No, not 0 plus 0. It's 0 equal to 0. And 0 equal to 0 is always true, right? If 0 is equal to 0, that's always true. So therefore, any number of x, as long as it's a real number, meaning it's like rational or irrational, as long as it's a real number, defined number, then this equation holds true. So actually, this is all real numbers. And we use this abbreviation ARN for all real numbers. You can use some other abbreviation as long as I know it's all real numbers, right? So whenever the right side and the left side are similar like this, or you cancel everything out and get something like 1 is equal to 1, or something like 3 is equal to 3, then you're going to have all real numbers as your answer, because no matter what is x, you can plug in 1 as x and the equation will still hold true. You can plug in 2 as x, 3 as x, 4 as x. You can plug in anything as x and the equation will still hold true, right? So there's another type of case where there's no solution. So for example, if you have 2x plus 4 is equal to 2x plus 3, you can see the 2x's cancels out and you get 4 is equal to 3. Obviously, this is not true, right? 4 does not equal to 3. And this is also no solution because no value of x will satisfy this equation. Okay? Because 4 does not equal to 3. So if you solve an equation and you cancel most things out and you're left with equation like this, where you have 2 numbers on the same side, on different sides that are the same, like 0 is equal to 0, then it's all real numbers. If you cancel everything out and you get like something like an untrue statement, like 1 is equal to 2, or like 4 is equal to 5, then that's not true, right? So there's no solution on that one. So those are a couple cases on where there's all real numbers, or where there is no solution. So are there any further questions about this topic? If not, we can move on. So are there any questions about this? So if there are no questions, then I'm going to move on to inequalities. All right, let's see. Oh wait, there's inequalities after that. All right. So before we move on to inequalities, I also want to cover a bit more about linear equations. So I guess we call these multivariable equations, where you have these couple of variables, right? More than one variable, basically. So does anybody recognize this? This is the equation for converting like what Celsius to Fahrenheit, right? So how do you actually solve for multivariable equations, right? So when you had a linear equation with one variable, right? And when you had a linear equation, you had one answer, right? Because you had one variable, you were able to get an answer, either no solution, all real numbers, or just one answer. But when you have multiple variables, then it's you can't really get a number answer, right? So instead, you're going to choose a variable to solve for. So let's choose solve for f, for example, f as in Fahrenheit, right? So you don't need to solve for c because it's already solved. So what does it mean to solve for f? That means to isolate f on one side and everything else on the other. And that's exactly what we've done with c already, right? Because we've already solved for c, because only c is on one side and everything else, f and numbers, are on the other side. So essentially, you're treating the f variable as a numeral in this case when you're solving for c, and you're isolating similarly with the other numbers. So when you solve for f, you're going to do a very similar process by essentially having c be a number and isolating c and all the other numbers to one side and f to one side. Okay, so when you do this, you similarly use the inverse operation, right? It's very, very similar to the linear equations. The only difference is that there's more than one variable. Okay, so when you solve for f, let's rewrite this with, first of all, you could distribute this. You could distribute. I would not, definitely do not recommend distributing it because 5/9 times -32 is an extremely ugly number. You do not want to deal with some fractions like that. So what I advise you to do is you want to multiply both sides by 9/5. When you multiply both sides by 9/5, then 5/9 and is all canceled out. So then you get f minus 32, 9/5c plus 32 is equal to f. And there you have solved it. This is f, right? You don't have to worry about c still being there. Solving for f basically is just isolating f and putting everything else on the other side. And so, and you might ask, why is this important that we need to know this? Obviously, you know why linear equations are important, right? You can solve a lot of word problems with them, real life scenarios, right? All that kind of stuff. And what about multivariable equations? So in science, like chemistry, for example, chemistry and biology, there are a lot of mathematical theorems actually with multiple variables. So for example, let's say, what is some chemical equations? Maybe like, what was it? How about this? PV over NT. All right, I think this was the combined gas law in chemistry. So the combined gas law in chemistry, you basically you solve for the gases, right? This is one of the chemistry theorems, right? And you want to solve for like V1 or something. Then you have to move everything to the other side and then do everything, right? It's very similar to a multivariable equation. Actually, that was a bad example. How about this? PV is equal to nRT. This is the ideal gas law. So this is let's solve for this actually. Won't take long. So for example, if you want to solve for T, which stands for temperature, you can't just like guess, right? It's very hard to guess when you have decimals in there. So this is where this multivariable equations is important. You need to know this. You can use inverse operations to just divide NR from both sides and you get PV over NR, right? It's very, very simple. So with this, you can solve for each variable and come up like with a little formula for this variable. So T is always going to be equal to the pressure times the volume over the number of moles times the R value, right? Or whatever chemistry equation, whatever biology theorem you're doing, because there's a lot of mathematical applications in chemistry and biology. So in case you have this, or even physics, right? There's a lot of mathematical theorems in physics, and you often have to solve for them. So I think I have another example, like A plus P plus no, A is equal to T plus PRT, right? So I'm pretty sure this is another theorem from somewhere. But if you want to find P, right? It's already solved for A, so let's solve for P, right? Solve for P, okay? So when you solve for P, in this case, you actually have to factor a little bit. Okay, so let's factor a little bit, right? So let's get a volunteer because I've talked a lot. So let's see, who wants to volunteer to help me solve this? Very similarly to this first example, right? So William this time, okay? How about William? William, how would you solve this? Solve for P.
So Wait, okay, I think. Oh, we first divide everything by p, like every term. So then it is a over p equals 1 plus RT. And
Very
then
good.
after that we do the reciprocal. So it's p over a equals to 1 over 1 plus RT. And then after that, we multiply everything by a. So p is equal to a over 1 plus RT.
Very well done. So this is one way to solve it. I would prefer you use factoring instead because it's much faster. So as you can see here, what is the common what is it called? The greatest common factor, right? The greatest common factor in these p and plus PRT, the greatest common factor is p, right? Let's factor that out, right? It's going to be p times the quantity of 1 plus RT. And you just factor that out. And all you need to do is just divide 1 plus RT from both sides. P is equal to A over R1 plus RT. So this reciprocal thing you did, right? It's very nice, but obviously factoring is faster. So make sure you don't forget factoring, right? So if you don't know how to factor yet, these simple factoring thing, we'll go over more about factoring and more advanced factoring in Algebra 2. But if you don't know how to factor yet, make sure you review that from the basic algebra. So that's how you solve for this one with the factor. And that's how you solve for a lot of these multivariable equations. You have to factor things. So, right. Okay, so now let's go on to inequality. So inequalities are basically, it's very similar to linear equations in the way that you solve them, right? So everybody knows that you solve linear equations with the inverse operations, right? You also solve inequalities with inverse operations. There's just a little key point here. The key point is that you need to flip the sign. So you need to flip the sign sometimes. So what do I mean by flip the sign? So there are a couple of signs, inequality signs. There's x is greater than a. This is x is greater than a. X is less than a, right? X is greater than or equal to a. This one you might not have seen yet. X is less than or equal to a, and those are all the signs, right? So obviously, pretty easy, right? You should not be having much trouble with that, right? These are the signs. Make sure you get familiar with them. So when do you what do I mean by flip the sign, and when do I flip the sign? So I know most of you should be familiar with the basic rules of inequalities. So let's everybody type in the chat if you know, when would you flip the sign in an inequality. So everybody try to type in the chat your answers, right? When would you flip the sign? Very good. Genevieve, when you multiply it by a negative number. Good. And also when you divide, but basically division is multiplication in a sense, because you're multiplying by a fraction. But yeah, when you're dividing and multiplying by a negative. Very good. So when you're dividing or multiplying by a negative number, you must flip the sign. And what do I mean by flipping the sign? When you have x is greater than a, that turns into x is less than a. If you have x is greater than or equal to a, it turns into x is less than or equal to a. Right? Very self-explanatory. How about unions and intersections? So this one, people might be so familiar about, right? So let's see here. So unions, what are unions? Unions, let's say a set, right? So actually I might want to go over interval notation again. Okay, so let's go over some things. So just a show of hands, how many people know or are familiar with interval notation? So if you're familiar with interval notation, raise your hand. or type in the chat if you want to. So who is familiar with interval notation? If you forgot, that's fine. So I don't think much people are that familiar with interval notation. Okay, kind of, right? Kind of. So I think a lot of people are in that region of kind of familiar with interval notation. So it's actually a very big thing. Right now in this first unit, we won't be using interval notation that much, but you need to know unions and intersections, very important stuff. With set theory, we're going to be maybe going through set theory, and also when you get into more inequalities, you need to denote them in interval notation, right? So it's very important mathematical notation that you need to know. So so first of all, this unit, I'm not really going to be doing any graphs, right? So graphs of inequalities, that's more basic algebra stuff. We're not going to be spending that much time graphing, because I'm sure you guys already know how to graph inequalities, that kind of stuff. So it's very self-explanatory. I'm just going to go over the answers to the inequalities. So let's see here. So if you have A is well, no, X is in between A and B, you're going to have AB, meaning that X is in the interval. X is in the interval of A and B. If X is in the interval of A and B, not inclusive, exclusive, not including A and B, you're actually going to have these round parentheses. So, and we're actually quite particular about that. So make sure you don't mix up the square brackets and the round parentheses. So when it's inclusive, A and B, you're going to use square brackets. When it's not inclusive, A and B, or you're not, it's only less than and strictly greater than is round parentheses. And when A is less than, let's see, X is greater than A, for example, then you're going to have A to infinity, because X just has to be greater than A. It doesn't specify if X has a limit, right? So it's going to be A to infinity, and you might want to notice that infinity has a round bracket. That's because infinity it's not really tangible yet, right? So that's why we use a round parentheses when we have infinity. So similarly, when X is less than A, then you have negative infinity and A. Okay. And so what are intersections and unions then? So unions, basically you're combining, and intersections, you're basically cutting out the parts that are not similar. So let me explain this in more detail. So let me clear up some space here. So first of all, did everybody understand a little bit about interval notation? Does everybody understand interval notation now? So there should not be much questions on this. Interval notation is not that hard. It's not that hard, really. So it's very simple. Unions. So unions. Let me explain this actually with Venn diagrams. Okay, so you have A here. This left circle is A. This right circle is B, right? Then the union, it's exactly what it sounds like. Your union, basically, you're putting them together. So when you have A, for example, is a set of numbers, B is also a set of numbers. When it's A union B, it's basically just adding all those numbers together. So everything is fair game, right? All the numbers in B, all the numbers in A, whatever, it's all in A union B. You're just adding them together, right? Okay, so what about A intersection B? It's going to be quite the opposite. When you have A with your left hand set, B with your right hand side, here set A intersection would be, notice it's an upside down U this time, right? What you're doing, instead of taking everything, you're actually taking what's the intersection, which means what is similar? What is similar between A and B? So it's actually going to be this middle part here. What is common? Which numbers are common between A and B? Maybe A has 2 and B also has 2. Then 2 is going to be within the set of A intersection B, right? So does everybody get the concept of union and intersection? Yes, okay, very good. So that's basically union and intersection. So now we can start with a little bit of this. So remember, and we used to, in basic algebra, sometimes we had a notation like x is greater than a or whatever. Now we're going to, instead of using x is greater than a, usually in algebra 2 and all levels up, you're going to denote this in interval notation. So let's just try this. So who wants to volunteer for this? Who wants to solve this? This is a little bit of review because you just use inverse operations to solve this. So who wants to solve this? So you have 4 hands here. Very good. So how about, who have I not heard of yet? How about Genevieve? Genevieve, would you like to volunteer?
Okay.
Okay. So how would you do this?
You would start by multiplying by 3, I guess.
Are you sure about that? If you multiply by 3, sure, this is canceled out, but this is not canceled out. This is not canceled out. So
Okay.
instead, what
Move
do you
the
need to
6
do?
to the other side.
You could move the 6 to the other side, but you're still going to have to multiply something to both sides, right? So instead of multiplying by 3, you're not canceling out 2. So what we're going to do is you're going to multiply 3 and 2. You're basically multiplying by 6 here. You're taking the least common multiple of these denominators and multiplying to both sides, right? And then you can cancel out the fractions because we hate fractions. They're too hard to work with, right? So we don't actually need to move the 6 to the 8 yet. So let's just multiply. Multiply is usually the first step, okay, to get rid of fractions. So if you're multiplying by 6, all right, Genevieve. So if you're multiplying by 6, what would this equal to if you're multiplying by 6?
24x over 3 minus 1/3 minus 6.
All right, so before you multiply the tops here, what you want to do, so let's look at this over the corner for a second, and I think this is helpful for everybody here. So instead of just multiplying the tops, actually distributing everything, it's going to be very ugly and crazy. It's going to be like 24x minus 18 over 3, and then you have to divide by 3, and it's going to be very tedious. So instead, you can actually cancel out this 6 and 3, right? 6 divided by 3 is 2. So essentially, what you're actually doing here is going to be, you're actually multiplying like this. 4x minus 3 times 6 over 3 is going to be 4x minus 3 times 2. So that's essentially what we're doing, right? So instead of multiplying everything out, you can actually just multiply 4x minus 3 by 2. Don't forget, you have to multiply 8 by 6 as well. 48 is less than 6 times 6, which is 36. Plus, and here's another one. So instead of multiplying everything out, what you're doing is you're going to multiply 3 times 3x. right? Okay, so now, Genevieve, could you help me distribute all of these?
8x minus 6 plus 48 is less than 36 plus 9x.
All right, very good. And can you combine like terms too?
Yeah, move the 8x to the other side, and then 48 minus 6 is 42, and then 42 minus 36 is 6.
So then we get x is greater than 6. So does everybody agree with this answer? So say yes in the chat if you agree with this answer, right? Does everybody agree with these calculations? Let's see here. So hopefully everybody agrees. Yes, okay, very good. Looks like everybody agrees. So then we get x is greater than 6, right? So you get x is greater than 6. So instead of using this notation, let's try to put it in interval notation. Now, everybody, I want most people to participate. So how would we put this in interval notation? So can everybody put in the chat your answers on how to put this in interval notation? All right. So infinity to 6. Very good. Well, not really. Actually, 6 to infinity should be the correct answer. So what you want to do, you have to pay attention to, so Genevieve, it's not going to be infinity to 6, it's going to be 6 to infinity because the lower number is going to be on the left. So just very particular about that. So make sure you pay attention to that detail. Okay. So all right, let's do another example. I want another something else. So I might ask something like this. Okay, so hold on, let me make some space over here. Okay, so this example requires a little bit of critical thinking. Okay, so you have 7 minus 2x, for example, and you're asked the question, for what value of x does square root of 7 minus 2x represent a real number? All right, pardon the handwriting, is very bad. Okay, square root of 7 minus 2x. Okay, so for what values of x does the square root of 7 minus 2x represent a real number? Right. So what you can do here is require a bit of critical thinking. Think about what this means. So first of all, the first thing you want to notice is square roots. Those are pretty bad, as well as similar to fractions, pretty ugly things, right? You don't want them. That's why you square them away. Then you simplify, right? So because square roots are a little bit hard to work with when it gets complicated. So square roots, they come with a special restriction. And the argument inside the square root must be greater than or equal to 0, because you can't square root a negative number, right? You can't have square root of -4, right? That'd be equal to like 2i. But we're not going to talk about that yet. We're going to actually talk about that next class with complex numbers and imaginary numbers. But right now, it says represent a real number. So we can't square root a negative number. So then you must set 7 minus 2x, the argument, greater than or equal to 0. And then it's very clear x has to be less than or equal to 7 over 2. And you can also put it in interval notation, negative infinity to 7 over 2. So make sure when you get to these problems, look for restrictions, because restrictions often have inequalities involved. Right, so look for restrictions here. Restrictions are very important. All right, and also today I'm going to be going a little bit over time because I arrived late. Very sorry about that. 15 minutes, maybe 10 minutes, okay, to make up for lost time. So now we're going to go over some absolute value inequalities. So what are absolute value inequalities? So let's recall the definition of absolute value. So can everybody tell me what is the definition of absolute value? Oh, yes. You have another class at 6. That's great. Okay. You can leave, of course. Sorry about being late today. So but anyways, I'll post the recording on the Google Classroom, so you can always review that. Okay. And William says the distance to from zero. Okay, very good. So that is one definition of absolute value. Another definition of absolute value is it's going to be the algebraic definition of absolute value. So the distance from zero is basically the geometric definition. And we're learning algebra, so we want to know the algebraic definition. So this definition may seem a little bit self-explanatory, but it's actually very useful. So x, the absolute value of x is going to be equal to x, positive x, if x is greater than 0, and negative x if x is less than 0. So for those who have taken a class with me, a basic algebra, you might have seen this definition before. This is very important because when you have the absolute value of square root of 5 minus 7, you can actually evaluate that. So let's look at this for a second. The square root of 5 is going to be like 2 point something. It's going to be 2 point something because the square root of 4 is going to be 2. So the square root of 5 is going to be a little bit bigger. It's going to be 2 point something. And obviously 2 point something minus 7 is going to be negative, right? And this definition precisely says that if your argument x is less than 0, it's going to be negative x. So essentially this absolute value, you can actually take this bracket off by taking the negative value of square root of 5 minus 7. And essentially what you get is 7 minus square root of 5. Now, let me give another example about the absolute value. So another value, so basically, if you have 16 minus pi, for example, 16 minus pi is going to be positive now. So your argument x is actually greater than 0. So then it's just x. There's nothing that can be done because it's positive already. You don't have to put a negative sign to it. Okay, so that's basically absolute value. And you have to take in this absolute value definition. And with this absolute value definition, then you can solve absolute value inequalities. So an absolute value inequality. So there are a couple of scenarios for absolute value inequalities. So the absolute value inequality, when you have ax plus b is less than c, right? You're going to have ax plus b is going to be in between c and negative c. That is one scenario. You have to make sure, pay attention to this, right? Is your absolute value argument less than something? If it is, then it's going to be in between that and its negative. Second scenario, if ax plus b, the absolute value of it is greater than c this time, you can combine it into some compound inequality. You're going to have ax plus b is going to be greater than c, or ax plus b is less than negative c. Then you get this, right? Ax plus b is greater than c, or ax plus b is less than negative c. So to interpret geometrically, you can kind of visualize this. When ax plus b is in between something, the inequality is going to look like this. X is anything within this interval. But if ax plus b is greater than c, or ax plus b is less than negative c, then you get something like this, branching out like this, right? That's the difference when it's greater than that, okay? And you really have to think about the definition of the absolute value in order to come to this conclusion to fully understand the absolute value inequalities. So can we just solve this from right here, right now? Probably not, because we need to move this -2 to the other side first, and then we get one of these scenarios. So let's just do that real quick. It's going to be 7, right? So now, look carefully. It is going to be less than or equal to something. Therefore, it's scenario 1 here, right? So then 5x, and see from our definition here, 5x minus 3 is going to be less than or equal to 7, or greater than or equal to -7. It's going to be in between that and its interval. It's going to look something like that. Okay, and then this is a compound inequality, right? So you can actually solve this. You can actually solve this both sides at once, right? So add 3 to both sides at once, right? Simultaneously, 5x is going to be less than or equal to 10 and greater than or equal to -4. Then finally you divide by 5, obviously. Then you get -4/5 is less than or equal to x is less than or equal to 2. Then what you get this, right? You get this interval -4/5 to 2, right? Now, if this absolute value was greater than something, then it'd be a whole nother scenario, right? Make sure you pay attention to the sign. Okay, so that's basically absolute value inequalities. That's a little bit of review, and we also added a little bit about the intersections and the unions, which we will be using later on. So now let's look on to absolute value equations, which you might not have gone through before. So absolute value equations are different. Okay, let's see what's on the side. More on absolute value. Okay, that's fine. So again, absolute value equations, like those first linear equations that we talked about, you have to check these. You have to check these as well. So let's see here. Let's see what we can do. Okay, how about this? So let me give you a scenario here. So when ax plus b, the absolute value of that is equal to c, that is basically an absolute value equation, basically very, very similar to an absolute value inequality, but not. There's an equal sign. That implies that ax plus b is going to be equal to plus or minus c. It's either equal to -c or +c, plus or minus c. And then you can solve. You're going to get 2 solutions. But another big thing here is remember to check, because one of those solutions might not work when you plug it back in. So make sure to check. Let's do a couple of these examples. So any volunteers? Okay, William. All right. How would you solve number 1?
For number 1, I just do 2x minus 1 is equal to a, or 2x minus 1 is equal to -8.
Right.
So then after that, I subtract 1 to -8 and 8. So 2x is equal to -9 or 7.
Are you sure about subtracting?
I mean add, and then that just means 2x is equal to 9 or -7. And after that, x will equal to -7/2 or 9/2.
Great. Very good. So then you get yeah. Very good. So let's check these. Let's see here. Yes, these both work. So these both work. Very good. So William, also try to solve this one for me. Okay.
Okay. So wait, so this just means x plus 4 is equal to 3x minus 8, or x plus 4 equals to negative 3x plus 8. And then after that, we add 4, subtract 4 to both of the sides. So x is equal to 3x minus 12, or x is equal to 4 minus 3x. Or 4x is equal to 4, and then that just means x is equal to 6 or 1.
All right. So could you check for me? Do you know which one does not work?
So 1 plus the absolute value of 5 is equal to no. The 1 doesn't work.
Good, because when you plug it in, you get 5 is equal to negative 5. So remember to check. 1 does not work. Only 6 is the correct answer. Very good. So let's see what we have next. So, oh yes, more on absolute value. So let's see here. Okay, so let's do one more example. This one is quite peculiar. So x plus 9 is equal to x plus 9. So you have basically the same thing on both sides. So how are we gonna actually do this? So you might come across this. I don't think it's very possible, but you might come across this type of variation. So I'm gonna talk about it. All right. So we're gonna do, of course, follow the regular procedure. X plus 9 is equal to positive x plus 9. And then x plus 9 is equal to negative x minus 9. It's basically negative x plus 9 here. But we simplify that, so it's negative x plus 9. Okay. All right. Well, negative x minus 9. Okay. So we could solve for these. So obviously here you cancel everything out. You get 0 is equal to 0. Huh. That's all real numbers, right? So what about this one? You move this to the other side and you move this to the other side. Then you get 2x is equal to negative 18 and x is equal to negative 8. No, not negative 8, sorry. Negative 9, right? So you get two different solutions that are completely contradicting, because one solution says you have all real numbers, but the other solution says that there is only one solution. That's kind of contradicting. So again, you want to check on this. You want to check. So always check. All right. So what we're gonna actually do is we're gonna find a number line so you can visualize properly. So you have 9 right here. We know that x is equal to negative 9 because if you plug it in, if you plug, you check negative 9, it's gonna work. It's gonna work, right? But what about all real numbers? It's not just negative 9, right? Because more numbers can work. So instead of what you're gonna do is you're going to check something greater than negative 9, and you're gonna check something less than negative 9. So let's check something less than negative 9. Let's check, for example, 0. 0 is less than negative 9. Okay? So then what do you get? Let's check 0. 0 plus 9 is equal to 0 plus 9. That works. Okay? Okay, first of all, why did I do that? Oh my gosh. That's so disappointing. Oh my god. Okay, sorry about that. Did I just say 0 is less than negative 9? Oh my God. Okay, anyways, 0 is not less than -9. Well, at least we know that 0 works, right? 0 is greater than -9. 0 is greater than -9. Okay. 0 is greater than -9. That means everything to the that is greater than -9 works. Now let's check what is less than -9. Okay, what is less than -9? -10. Okay, let's check -10. Then you get -10 after value -10 plus 9 is equal to -1. Okay, obviously you're gonna get 1 is equal to -1, which does not work. So therefore, the left side does not work at all. So then what you're gonna do is you're actually just going to get everything greater than -9. Right, that's your answer. Okay, are there any questions on this? All right. All right, so I think that's all we have time for today. I think I made up the 15 minutes that I was not here, so a full hour today. So thank you for listening, everybody. The Google Classroom, the link is going to be in the Google Classroom. So no, the link for the Google Classroom is going to be in the WeChat, and then you go to the Google Classroom, and then you go to the recording if you missed anything or you want to review anything. So that's all we have time for today, and I'll post the homework very shortly. Thank you for listening, everybody. I'll see you next week.
Thank you.
Probably.
Bye. You.